Is that a motorcycle or a car coming towards you? If you said it was a car, you are right. But why do we only seem to see one headlight? This is because we're not able to resolve the two headlights, or it means to distinguish between the two headlights. Before we explain how we can spot whether it is a car or a motorcycle driving at night, hey, you two, stop arguing. Let's first understand how light behaves. Light behaves like a wave when traveling through an opening and encountering an obstacle. To explain this phenomenon in simple terms, we need to explain Huygens' principle. Huygens' principle hypothesized that light is a wave in ether medium, and each point on the wavefront serves as an individual spherical wavelet that travels forward. As light travels through an opening, it diffracts at the edge of the wall, leading to interference and superposition. If the peak of the wave, also known as crest, coincides with another crest, the waves will constructively interfere, leading to a high intensity of light. However, if a trough coincides with a crest, it will destructively interfere, and no light will displace on the screen. Each wavelet may travel a different distance to the screen, thus some resulting in a path difference, which causes the original coherent light to constructively or destructively interfere at different points on the screen. Now that we understand how light diffracts, we can investigate resolution. Resolution is the ability to distinguish between two objects. But how do we know when can we resolve? When can we not? Looking at these two headlights, we are able to clearly differentiate them when we are close to them. But if we are very far away, we can barely do so. To determine the minimum condition to be able to distinguish two objects from one another, we need to look at the Rayleigh criterion. The Rayleigh criterion indicates the minimum angular separation, in which the primary maximum of one source has to coincide with the first minimum of the second source. We can use this formula for a flat opening and that formula for a circular aperture to calculate the minimum angle of separation. The minimum angle of separation also establishes the limit of resolution. An angle that is smaller than the minimum angle will only result in one object. By understanding resolution, we are able to enhance the resolving power of many optical instruments, such as telescopes and microscopes. So we may see two different stars in the sky, or two electrons.